Hello guys, here is section 4.5, day 1 notes. We are graphing tangent and cotangent functions. Alright, so for a tangent function, notice the difference between sine, cosine, tangent, cotangent is the period here is pi instead of pi over 2. And so half of our period, notice, is on this side of x, or this side of 0, and the other half is on the negative side of 0. So that is what we're going to be transforming here. So for example, number 1, it wants us to graph tangent 2x. So our normal period for tangent is pi. This is saying take the period and not multiply by 2, we're going to divide by 2. So the period for our new graph is going to be pi divided by 2. Remember, I just said half of that is going to end up on this side of 0, the other half is going to end up on this side. So I'm going to take this pi over 2 and divide that in half. So this is going to be minus pi over 4. This is going to be pi over 4. And at both of those places, I have an asymptote. And then we start low for tangent, and we end high. And so a lot of people have been asking about the amplitude. We still really have an amplitude here. We don't call it amplitude, but we still could have a vertical stretch or a vertical compression. And all that really means is like when we're about halfway between 0 and pi over 4, when we're at, say, pi over 2, we should be up here at 1 because there's a 1 out in front. And then again, when we're halfway between 0 and negative pi over 4, we should be at negative 1. I'm not going to get too picky about your graphs, but if you had one where you're comparing a stretch versus one that doesn't have a stretch, you would want to take note of where it's crossing. All right, so for you try A, again, typical period for tangent is pi. Our period for tan 4x would be taking pi and not multiplying it by 4, but dividing it by 4, so pi over 4. All right, and then half of this is going to go onto the left-hand side, and half is going to go to the right. So half of a fourth of a pi is an eighth of a pi. So negative 8 pi over here, and then positive pi over 8 over here. And then at both of these guys, we need an asymptote. And we're going to start low, go through the origin, and end high. All right, you try B. So again, this is going to be a period changer. Our typical period for tangent is pi. This time it says don't divide by 2, multiply by 2. So for this guy, our period is going to be 2 pi. Half of that's going to be on the left side, half of it's going to be on the right side. So on the left side, we're going to have minus pi. Right side, we're going to have pi, which means altogether this period is going to be 2 pi. All right, and then we need asymptotes at each of these guys. Oops, pretend like I went through that line there. And then we're going to start low, go through the origin, and end up high. All right, let's look at some more reflections, and how about some translations up, down, left, right. So for A, it looks like we just have a reflection, and then we have a period changer, a horizontal shift. Stretch. So first off, let's graph tangent of x over 2. Typical period would be pi, but the period for this one is going to be pi times 2, the opposite of that, so 2 pi. This is the guy that we just graphed. So here's minus pi, here's approximately pi. Both of those places we have our vertical asymptote, but the reflection means instead of starting low, ending high, we're going to start high, ending low. Sorry that's so wide there, I got a little carried away, but I hope you get the idea. All right, for B, we're going to start low, end high, because I don't have a reflection, but I do have a phase shift. So typically we would be at pi over 2, and then we go through 0, and then my other asymptote would be at positive pi over 2. But this is saying take all those numbers and not subtract 3 pi over 2, but add 3 pi over 2. So for my vertical asymptote, my intercept, my other vertical asymptote, we want to add 3 pi over 2. So 3 pi over 2 minus pi over 2 would be 2 pi over 2, which reduces down to pi. 0 plus 3 pi over 2 is going to be 3 pi over 2. Pi over 2 plus 3 pi over 2 would be 4 pi over 2, which reduces down to 2 pi. All right, so here at pi, I've got an asymptote. At 2 pi, I have an asymptote. And in the middle, I've got 3 pi over 2. That's where we're going to be going through the x-axis. So we're starting low, ending high on this one because we did not reflect it. All right, see the U-try. This one has a reflection and a horizontal shift, a phase shift. So our typical period is pi, and we split half of it on one side and 0, half on the other side. Remember, these are our vertical asymptotes. The guy in the middle is your x-intercept. But we are going to add pi over 6 to the opposite of what it says, and we're going to add pi over 6. 0 plus pi over 6 is pretty easy. The other two, we're going to have to do some fraction math. So I have minus pi over 2 plus pi over 6. So for this one, we need to find a common denominator, which would be 6. If I change this guy to a 6, we need to change this to, what do we multiply times 2 to get to 6? That'd be 3. So we change that to a 6, we're going to change this top to a negative 3. All right, negative 3 plus 1 would be negative 2 pi over 6, which reduces down to negative pi over 3. All right, and now fraction math on the other side. Pi over 2 plus pi over 6. Again, I need to find a common denominator, which we say is 6. This one stays the same. 2 times 3 gives me 6, so this is going to be 3 pi. So here I get 3 pi plus pi is 4 pi over 6. Reducing this guy, I get 2 pi over 3. All right, so we're going to start at negative pi over 3. Here's pi over 6. There's pi over 3. Negative pi over 3. This is going to be positive pi over 6. And then this will be 2 pi over, this will be pi over 3. And then this will be 2 pi over 3. I think I have that right. It doesn't seem quite right. See, this is 1 over 6, 2 over 6, 3 over 6. That's what I'm missing. There's 3 over 6, which is pi over 2. 4 over 6 is 2 pi over 3. There we go. You don't need the guys in the middle. It's just helping me space it out. So here's an asymptote. Here's my other asymptote at 2 pi over 3. And in the middle of these guys is where we're crossing the x-axis. And we're going to start high and end low because we've got a negative sign. So start high and end low. All right. And the next video, I'm going to do cotangent functions. So come back and I'll finish up example 3 and the U-try on the next video.